welcome to Impulse VLSI, where we make things possible. Let's learn most commonly asked interview question in the top semiconductor companies like Qualcomm, Broadcom, Intel, Nvidia, etc. The question is, what happens when input common mode
So let's
voltage
hear about
increases
it
for
by
an
an
op-amp?
expert.
The question to solve today is what happens when input common mode voltage increases for an op-amp. Let's assume 5T VOTA, which is mentioned in the left side diagram. So in this particular diagram, the input is given for the MOSFET M1 and the MOSFET M2. So when we give the input voltage and this input is now getting increased from existing level to the higher. So because of this, your output voltage will start decreasing because the VGS of this particular MOSFET and the VDS of this particular MOSFET tries to increase. Though the VGS of this M2 or M1 is slightly get increased because of this tail current source M5, so there is slight decrement in the Vout. So now the Vout minimum whatever we have existing will start dropping by some amount. If the Vout of this M1 and M2 starts dropping down, that essentially creates the issue of the VDS requirement. Now the VDS of this M1 and M2 will start getting decreased. If the VDS of M1 and M2 starts getting decreased, that will start creating the problem for the operating regions. So as we already know that VDS requirement for saturation is the VDS should be greater than or equal to VGS minus VTH. Now, since the VDS is getting decreased, then it starts getting entered to the linear region. That's a problem for an op-amp because all the MOSFET should be in saturation region only to behave as a perfect amplifier. Since it started getting into the linear region, that impacts its current, means that ID will decrease. This decrement in the ID will result in what? The decrement in the GM because the GM and ID are proportional to each other. So this results in the third impact, which is your gain. So now what is gain? AV is nothing but the GM times of R naught or R out. So as current is getting decreased because of the linear operation, the GM will also go down. Since the GM is going down, the AV will also get down. So these are the three different impacts that will get created when we decrease the input common mode range. Sorry, when we increase the input common mode range. To summarize, first impact of increase in the input common mode range is the decrease in the output common mode, right? In the sense, V out minimum will decrease, which means that effective output common mode range will get increased, which is good. The second thing is it also decreases the VDS of the MOSFET M1, VDS1 and VDS2 will get decreased. So this results in decrease in the IDS1, 2 that will get decreased. So that results in the GM decrement for 1 and 2 MOSFET. So that's the second impact. And the third impact is the decrease in the gain because the gain is nothing but GM times of R out. Correct? So this will result in the effective gain decrement.
I hope you found this video useful. Please help others by sharing this video. To know more such interview questions, please subscribe to our YouTube channel and to please follow our Instagram page, Impulse VLSI. If you have any specific questions related to VLSI, comment below. We will try to address them. Thank you.